I've always wondered why some fractions, when you convert them into decimals, they just never end, while others end at this nice, clean, finite point. Why is that? Why is it so? And how are we going to justify any kind of explanation here? If we look at 0.125, we could rewrite that as 125 over 1000. Whereas 0.142857 recurring, we're not going to be able to ever express this over a denominator of 1000. And we can see here that for something to end, for the decimal to end, then we're going to have to be able to express it as a fraction over some power of 10. So here, over 1000. And that makes sense because if we multiply the numerator and the denominator here by 5 cubed, we're going to get 125 over 1000. But here, it doesn't matter what we multiply the 7 by, how we scale up this fraction 1/7. We're never going to be able to make it to be a power of 10 because it's got a factor of 7 on the denominator. And that any power of 10, so we say 10 to the power of n, only has factors 2 to the power of n times 5 to the power of n. So if there's any other prime factors besides 2 or 5 on the denominator here, it's going to be infinitely recurring and can never be a terminating decimal like this one. So yeah, it all comes down to the fact that everything that we do is in base 10, and base 10 is made up of factors of 2 and 5. If you learned something here, then save this video, and if you think you've got a better way to explain it, please teach me. Let me know in the comments, and I'd love to read it.